It is algebra time again, and the lesson that's waiting for us is lesson 7-5, Graphing Systems of Inequalities. You're going to like this one because it's very similar to a lesson that we've already covered. This is a lot like lesson 6-6. Now, what we did in lesson 6-6 is we graphed single inequalities. And what we did is we took linear inequalities, we put them in slope-intercept form, we graphed them on the coordinate plane, and then we had to make sure we had the correct kind of line, either solid or dotted, and we had to shade the correct region above the line if y was greater than or equal to the equation, or below the line if y was less than or equal to the equation. Well, guess what we're going to do today? The same thing. Yep, we're still going to be graphing the lines and we're going to be shading the correct regions. The only difference is today we're going to have 2 lines and 2 shaded regions per problem. Now, what we're looking for in today's lesson is where the shaded regions intersect, or in other words, where they overlap. Because that overlapping region is going to be the solution set for our system of inequalities. So let's take a quick look at the notes. First of all, what we have to do in today's lesson is we have to make sure that both inequalities are in slope-intercept form. Now, you remember slope-intercept form is y equals mx plus b. But of course, instead of the equal sign, we're going to have one of the inequality signs in its place today. Now, after we have our slope-intercept form all taken care of, we graph both lines. Now, please remember that if y is greater than or less than the equation, then your line needs to be dotted. But if y is greater than or equal to or less than or equal to, then your line needs to be a solid line. Third, we shade the proper region. And again, since our inequalities are going to be in slope-intercept form, you just have to remember that if y is less than or equal to the equation, you're going to shade below the line. And if y is greater than or equal to the equation, then you're going to shade above the line. Finally, we're going to take a look at our graph, and we're going to find where the 2 regions intersect. And we're going to darken in that region in our graph to show everyone that that is the solution set. Sounds pretty easy? Well, let's take a look at a couple examples just to make sure that everyone knows what I'm talking about. Well, here's our first practice problem of the day. You see that y is less than 2x plus 1. Hey, they're being nice to us. That's already in slope-intercept form. So just by looking at that inequality, we can see that the slope is 2, or 2 over 1, and the y-intercept is going to be at 0 and positive 1. And then we take a look at our second inequality, the blue one. It says y is greater than or equal to negative x plus 3. Again, it's already in slope-intercept form. That's great, because just by looking at the inequality, we can see that the slope is negative 1, or negative 1 over 1, and the y-intercept is 0, 3. Now, that's all the information that we know right now, but it's all we need to know. We can take that information over to the coordinate plane, and we can graph those lines. Now, let's think about a couple things, though. The maroon line, it says y is less than 2x plus 1. You know what that means? That means when you draw the line, the maroon line must be dotted because y is not equal to the equation, it's just less than the equation. But when we draw the blue line, we're going to need a solid line because y is greater than or equal to the equation. If it's equal to, that means the line is solid. So now we know what kind of lines we have to draw. The maroon line has to be dotted, the blue line has to be solid. Now let's think a little bit about where are we going to shade the regions. Let's take the maroon line first. It says y is less than the equation 2x plus 1. Now, since y is less than, we're going to shade below the maroon line. And take a look at the blue inequality one more time. It says y is greater than or equal to the equation negative x plus 3. That means we're going to have to shade up above the blue line because y is greater than. Now let's go over to the coordinate plane and see what our graph looks like. As you can see, I graphed the maroon line starting at 0, 1, the y-intercept, and then I went up 2 over 1 because the slope of the maroon line is 2, and then I went ahead, connected the dots, and I used a dotted line, remember, because y is just less than 2x plus 1, so that means it's not a solid line, it's a dotted line. And since y is less than, you notice that I shaded below the maroon line. Now the blue line is a solid line. Remember we said that because it's greater than or equal to, the equal to means that it's going to be a solid line. And because y is greater than the equation, I shaded up above the line. Now, do you notice the region off to the right where the maroon and the blue regions overlap each other? Well, that intersected region right there is the solution set. All the ordered pairs that are sitting in that region would make both inequalities true. Now the other ordered pairs in the rest of the graph, they would make one or the other or both of the inequalities false. So the only region that we're going to say is the solution set is the overlapping region there to the right. Let's try one more practice problem just to make sure you understand exactly how to do these problems. Well, here we are at practice problem 2, and looks like the inequalities are not already in slope-intercept form. Well, that's what we have to do first because we want a nice, easy problem to graph. And of course we know that if your equation or your inequality is in slope-intercept form, it is going to be really easy to graph. So let's go ahead and get both of those inequalities in slope-intercept form. Okay, we've taken care of the problem. We've put both of those inequalities in slope-intercept form. First of all, the blue equation, we subtracted 2x from both sides. That gives us y is less than or equal to negative 2x plus 4. So now we know that the slope of the blue line is going to be negative 2, or negative 2 over 1. And the y-intercept is going to be at the point 0, 4. Now let's take a look at the maroon equation. Have to do a little bit more work on that one. First of all, we're going to subtract 3x from both sides. That gives us negative y is greater than or equal to negative 3x plus 6. Now we have to cancel out that negative in front of the y. Y has to be all by itself. So I did that by dividing everything on both sides of the inequality by negative 1. That leaves me with y is less than or equal to, don't forget that extra rule when you're isolating a variable during an inequality problem. If you multiply or divide by a negative, you got to flip that inequality sign. So that's why it's y is less than or equal to 3x minus 6. Well, that's slope-intercept form, and now we know that the slope of the maroon line is 3, or 3 over 1, and the y-intercept is going to be at the point 0, negative 6. Now, once again, let's get our plan in place. First of all, the blue line, y is less than or equal to. That means it's going to be a solid line, and it's going to be shaded below the line. And for the maroon equation, it's also less than or equal to. Now that means that the maroon line is also going to be solid, and we're also going to shade below that line. So let's go over to the coordinate plane and see what our solution set looks like. Well, here we have our finished graph, and as you can see, the blue line started at the y-intercept, 0.04, and then I went down 2 over 1 because its slope is negative 2. I drew a solid line because y is less than or equal to, and I also shaded below the line because y is less than or equal to. And you can see where the blue region is. Now the maroon line, I started at its y-intercept, which is 0, negative 6, and then I went up 3 and over 1 because the slope of the maroon line is 3 over 1. And then I made a solid line because y is less than or equal to, and again I shaded below the line because y is less than or equal to. Now if you take a look at where the maroon and the blue regions intersect or overlap, it's that upside down V-shaped region at the bottom of the graph. Now again, all of the little ordered pairs sitting in that region will make both of our inequalities true. So I hope everyone finds this lesson to be pretty easy, and I hope you do a fantastic job on your homework. Have a great one, and we'll see you next time.